Hello and welcome. For this video today, I'm going to talk about some Python code and a little project that I set up and just wanted to discuss. So the use case here is anytime you're getting into downloading virtual machines. I'm learning pen testing, but a lot of people are downloading virtual machines for all kinds of uses. And there's this concept of, so we're on the Kali Linux page as an example, and the the hash of the particular file that you're going to download, you'll see that that's commonly provided, and that's just to make sure that if you're on the official web page and you are getting the official release of a certain virtual machine or a file, that the developers are providing the hash of that file. And so that way, when you do download it, you can test for yourself and see if the hash matches, run the same type of hashing algorithm against that file and see if it matches or not. Because if it doesn't match exactly, then you don't have the exact same file, and it's possible it could have been modified in transit, or you have a file that is not actually from the official developers. So yeah, just basically wanted to make sure that whatever file that you downloaded from the official source and you run the hash algorithm against it, that you'll get the exact same hash value. Because if one bit has been changed in that binary, then it's going to have a different output. So really good use of the hashing functions for that. So there's plenty of different ways to do this, but I just thought this would be a really good example. I can just make my own program, and specifically in Python, just what should be a relatively easy project to do. And then there's ways that you can kind of enhance it, and it's a good example. So I'm just going to run through the code here real quick. So there aren't that many functions. There's a welcome message. This is meant to be kind of interactive. So print a message to the person that starts the program and specifically say, here's the supported algorithms. So how are we going to get that information to the user? Using the library for the different hash algorithms. So within this code library, this hash lib, there's a function hashlib.algorithms guaranteed, and then this is just basically saying this will return a set of hashing algorithms that are guaranteed for this particular module. And so basically I'm making this set isn't going to be the data structure that I need. I need more like a list, because a set you can't really get an index of or use it the way that you would like with a list. So basically I'm getting a set of those different hash algorithms that are going to be guaranteed for this module that's being used. And so I'm storing that in this hashes variable. Now the problem that I found, first of all, I was not even aware of these shake 128 or shake 256 algorithms to begin with. And when I was testing this program, I found that I was getting a type error when all the other ones are working. I didn't really understand what was going on there. So going into the documentation, I found that this shake algorithm actually requires an input or an argument, so you can say what the length of the output is going to be, which is different from the other types of hashing algorithms. And so now I could have modified the program so that when you if you were to select this, then you would pass in the value that you wanted, but that didn't really seem like worth the time or really kind of in the scope of this program. So basically what I'm going to do is I'm just going to not show that to the user. So basically I'm iterating through this hashes set, and if the value in that current iteration is one of these shake algorithms, then I will just continue to iterate through. And then, but if it's not, then I want to append that to this supported algorithms list that I have created. So all I'm doing is taking this set that's returned from this guaranteed algorithms function, and then iterating through it, and then everything in that set that doesn't match this one of these two shake algorithms, then I'll just append it to this list, and then this function returns that list. So now I have a list of the supported hash algorithms that I can show to the user. And I do that in print supported algorithms. So that one takes an argument here, which is meant to be a list. And then but then I want to sort those because the list at this point is not sorted. And then when I pass it in here, I'll just sort it. So you can just easily run this sorted method, and that just by default does it alphabetically, which is what I want. And then, so now my list supported algorithms, just iterate through that and print the values. And then, so now need to gather the user input because it's meant to be interactive and just have people type stuff in. One of the ways that this could be extended that I might do is just make it so you can just put things, you can just put this in on the command line arguments and not have to have the user put this in unless they don't specify the command line arguments. In that you'd use the argument vector. So I may update this program to do that. But so first input, enter the hash algorithm to use, and they've already been shown a list. Store that in the alg variable. Enter the path of your file. The cool thing about the we'll see here in a minute is if this script or this Python program is running in the same directory as the file that you wanted to use, then you can just put the file name and it'll take that. But if this is running from some other directory than where this particular file that we want to check against, that's fine. You just put the absolute path in, and I'll do that in an example here. And then so the whole point of this is you have a reference hash that you want to check it against. So you have a file, you have the hash that's provided by the developer, and so you're just going to paste that in. So the user is saying, I want to use this particular algorithm. My file is in, I can just put in a file name if the program is running from the same directory, or the absolute path to that file, and program binary or whatever. And then what is the hash that I'm wanting to make sure that it actually matches against the output value. And so then I just take those three, put those into a list, and that's my user input. And so these are just all basically going to be strings. And yeah, and then so the gather input returns the user input. And so that the result of this, the return of this function is meant to be the input for the hash checker, which is essentially now we're going to start running a hash algorithm. And you'll notice that I have exception handling here with this try block. So we're going to run get supported algorithms. We got the set, the list of the algorithm types that are supported, and then the user input that we passed in here. Each element of that we're going to put into a variable accordingly. So index 0, user algorithm, sub 1, user the path, sub 2, the reference hash. And then, so now we're just checking if they put in something for their, the algorithm type that they want to use that doesn't match the list, then we need to account for that. So basically I'm saying user specified algorithm is initially false. And then I want to iterate through the supported algorithms that have been passed in. And if the user algorithm matches one of those, then we'll say that their specified algorithm is true, and then we'll break out of this. But if we run through that list of supported algorithms and what the user specified does not match, then this variable remains false. And then if the user specified algorithm is true from up here, then we'll run this code. But if not, then we'll catch this on the else here and say, and just print out an error. What you supply doesn't match the list, can't move forward. But if they do type it incorrectly, then we're going to call this hashlib.new. So this is like the constructor for the type of algorithm that you want to use. And that's why the shake algorithms don't work in this case, because you have to pass in, the constructor works slightly different from those. You have to pass in as an argument the output length that you want. And so it doesn't make sense for this particular use case here. So at any rate, though, we're calling the hashlib constructor for making an object that we of a particular hash algorithm. So if the user put in SHA-256, then we're making a hashlib object that's of type SHA-256. So then we can operate on that object. And then so we need to open up the file path that they supplied, whether it's just the file name because this program's running in the same directory, or the absolute path. Either will work. And then we're opening it up in read-only and binary mode, and the binary part's important here. So we're opening up that file that the user supplied, and then calling read on that. So now we basically have a bytes-like object, essentially. We have a binary stream here that we can do something against. And then, so back to the hash object, we want to run the update method against it. And then once we have that, we want to run the hex digest. And after we've done that, so we created a new hashlib object. We ran the update method against that that byte stream of the file that the user made or provided, and then we run the hex digest function, which is ultimately going to give us the actual text or string value of the hash of that file. And then we basically just say we need to check, does the hash value, the output of us running the hash against that file, does that match the reference that the user provided? If it does, and we say success, your supplied value matches, and here's the output value. If it doesn't, then failure, and your supplied value does not match. And if there was any problem opening up, so as far as the error checking goes, then if there was any IO errors, like there was a problem opening up this file or like it didn't exist or something, then that'll be caught here. And then any other exceptions just get raised and will be caught in this last function that I want to talk about, which is run program. So this is just pulling together the rest of the code here in some kind of organized way. So we have exception handling here. So any exceptions will be, since the only code that we're running here is just run program from the top, anything that runs inside of that is going to will have good exception handling. And the only difference with the one above it is just to catch the IO error specifically, and anything else raise. But so we're going to run the welcome message, and then get the supported algorithms, print them out, and then gather the input from the user, run hash checker against it, and then just print out whether it worked or not. So then I've got some examples. So I'm going to run Python 3.9 hashcheck.py is the file. And then you can see here it's showing welcome to hashcheck. Here's the supported algorithms. I'll do SHA-256. And then the path. So this is about a like half a gig file. It's actually the file for VS Code, the IDE that I'm using here. So I'm just pasting in the absolute path to that, and then the reference hash to check against. So this is provided by the official site for VS Code by Microsoft. So they're basically saying when you download a file and run SHA-256 against it, then it should be this value. And then that's the whole purpose of this program. So success, your supplied value matches the hash that we computed here on this local computer. So that's cool. If I put in garbage data, so we'll say just something that doesn't match, we'll just put in complete garbage data. But the first thing was a hash algorithm that just doesn't exist here. And then, so we can see user specified algorithm doesn't match. Let's put in something that does work. So we'll do MD5, and then, but let's just put like some garbage path, like /bin/test.py, and then some other thing that doesn't work. So we put in, a file that just doesn't, a path to a file that just doesn't exist. And then OS error, opening the file, no such file or directory. So we can see our exception handling is working there. And then, so we'll run this one more time. We'll put in SHA-1. We'll put in a valid, we'll actually even just do, just to show. So I'm in the same directory as this hash check. So I don't have to put a path. I can even, in this particular case, I can just put the file name. And now, this is not going to be the hash of the particular program. And then you can see failure. So what I put in for hash value doesn't match. And this is the actual SHA-1 against this program that I'm running. So that all works for like smaller files. But, what happens if you have like a 5 gig file or something larger? Then another thing that I'll likely do with this program is put in some code to like spawn a new thread when you actually run the hash checker function, and kind of update the user every 10 seconds or something, like still working on it or whatever. Because what we'll see here is I'm going to run SHA-256 against like a 5 gig file, and it works, but it takes like up to possibly 30 seconds, I think, or somewhere around there. So the problem with the program is it's just going to sit there until it finally finishes, and it would be better to just like spawn another thread, put some like updating message every couple seconds or whatever so you can see it's still running, and then when that thread's done, then it can come back and finish the program. So that's not in here right now, but very likely that's something I'll do because I haven't worked with spawning threads in Python. So good, easy way to jump into that. So let's run it this last time, and I'm going to say SHA-256, and then I'm going to put in a path to a VM file that's like 5 gigs, and this is going to take probably 30 seconds to run, and then pass in my value of the hash that's actually correct. Okay, so that's going to run, and you can see there's not really any help to the user to see that it's still going. So while that's running, I just want to point out a couple of things. So, looking into the documentation, I didn't understand why the shake ones were failing when I was testing this originally. I had to look in the documentation and then finally realize when I started looking at these specifically that this is why it wasn't working, is because the constructor for these requires an input length that didn't work for my program. The reason why I bring that up is like one of the biggest things that I learned like in college and computer science stuff was learn to read the documentation and try to solve problems by reading the documentation. There's many examples of that, and this was a good example that like really helped me out, because otherwise I was just getting a type error and I did not understand why it was failing and the other ones were working. I'll put a link to this video, which is really good, extremely straightforward. I just like how to just start a new GitHub page, upload your, like basically the assumption here is you have Git running on your local machine. But then as long as you have Git installed and running on your local machine, this is a very straightforward video of like how to initialize the directory, how to stage your files and push those to your GitHub repository and from scratch. So excellent video. I'll put a link to that. And then, yeah, so the other part of this whole like mini project was to, for the first time, get my own GitHub page up and then push this code up once it at least was in kind of a working state that actually does something properly. And then of course it can be added to modified later and stuff like that. So yeah, that's the main point, is read your documentation. Here's a really good thing if you haven't started your GitHub page yet. And then just an example, this was very straightforward and easy to do for the first time, and then I can just keep progressing from there. So now that I've talked about all that, we can see that in fact the program did come back against that 5 gigabyte file. And there might be upper limits. Another thing to look into or possibly test are like much larger files, and then this code may not support super large files, like because of RAM limitations and things like that. So it's possible that would need to be modified to take that into account. But yeah, against a 5 gig virtual machine, success, the hash is matched. So yeah, that's pretty much it. So this is kind of just like a walkthrough motivational video to just show it's not that difficult to get things started. And then you can look at the code online and then modify it for yourself if you want. So thanks for watching and have an awesome day.